Welcome back, everyone. Before the break, I had just defined how we would find A, B, and C for a quadratic pattern. Now we're going to look at some examples of quadratic patterns, and we are going to find A, B, and C. Let's have a look at our first example. So the question says that we are given the sequence 2, 10, 24, and 44. We have 3 questions that we're going to work through together. A is asking me to determine the general form of the sequence, and we know the general form is Tn is equal to An squared plus Bn plus C, so we still need to find A, B, and C for that. We're then going to determine the value of the 12th term. Then we're going to determine which term will have a value of 290. So we have a pattern and 3 specific questions about that pattern. Let's go to the board to start working on our general term. So we've got the sequence that goes 2, 10, 24, and 44. The first thing that I'm going to do is I'm going to look at the first differences of the pattern. And just a reminder, the first differences are the differences between the actual term values of the pattern that you are given. So between 2 and 10, we can see that there's a difference of positive 8. Then between 10 and 24, we can see there's a difference of positive 14. Then between 24 and 44, we can see there is a first difference of 20. I'm now going to look at the second differences. I hope that everyone will agree with me. This is not a linear pattern because my first differences are not equal to each other. Looking at the second difference, between 8 and 14, I can see that positive 6 was added. Then between 14 and 20, I can see that positive 6 was added. So my second difference is positive 6. Now I'm going to calculate the general term of the following sequence. We know that we need it to be Tn is equal to An squared plus Bn plus C. So if you remember what we did before the break, let me just erase that. That's a bit of a squiggle. Let's go back to the pen. 2a is equal to my second difference. And in this case, my second difference is 6. So if 2a is equal to my second difference of 6, we can see that a will be equal to 3. I then said that 3a plus b is equal to the first term of my first differences. So the first term of my first differences is 8. So 3a plus b will be equal to 8, but I'm going to substitute in a is equal to 3, which I found above, in order to find b. And I'm hoping that everyone will agree with me that b is equal to negative 1. Now, last but not least, I need to find c, and a plus b plus c is equal to the first term of the sequence, and in that case, it is equal to 2. So I'm just going to swap color so you can see me substituting in the values. I found that a is 3, so it's going to be 3, plus b, which over here I can see is negative 1, plus c is equal to 2. What's going to happen is I'm going to have that 2 plus c is equal to 2, so actually c is equal to 0. We've found the values of a, b, and c, but I'm not done yet. I need to conclude in the general form of the formula. So let's conclude the general form for this specific quadratic sequence. Please turn to the board with me. It's going to be Tn is equal to 3n squared, because that's my a value, minus n, and I'm not going to have a c value. So normally we have a plus c, but it's just going to be 3n squared minus n as the general form for the sequence because I do not have c. We're now going to move on to the next example. So behind me, I've repeated that the general form of this quadratic sequence is Tn is equal to 3n squared minus n, and we're going to use that general form in order to help us answer some questions. Let's have a look at B together. So we are given the sequence and we have just determined the general term. This was a part of question A. We are now going to determine the value of the 12th term. Everyone at home, if I'm asking you for the value of the 12th term, does everyone agree that I'm looking for the value of term 12? I'm not looking for which term has a value of 12. I want to know if I were going to zoom in on term 12 of this pattern, what would that value be? Let's look at the board together and we're going to solve it. So we are going to substitute in n is equal to 12 because I want T12. I want to know what the value of T12 is. So T12 will be equal to 3 times 12 squared minus 12. So all that I've done is I've substituted in 12 for n. Then if you type that all into your calculator, I'm going to type it in with you. We're going to have 3 times 12 squared minus 12. So we can see that the value of the 12th term is 420. Let's move on to question C. So now that we've worked out the value of the 12th term, the next question is actually going to give you a value of a term, and you are going to determine which term actually has a value of this specific number. Okay, so let's see what number we actually have to see the term matches to. So C asks us to determine which term will have a value of 290. This is not the 290th term, so it's not the 290th term. I want to know which term number has a value of 290. So I'm going to substitute in 290 in for Tn because that's the actual value of the term. So it's the actual value, which will be equal to 3n squared minus n. I'm going to carry the 290 over, so it's going to be 3n squared minus n minus 290. And I hope that everyone can see that I've now got a quadratic equation. And if I factorize it, I'm going to have 3n plus 29, n minus 10. So n will be equal to 10, or n will be equal to negative 29 over 3. But I'm hoping there's some alarm bells going off in your head. Can I have a negative term value? Do I ever ask you to find the negative 29th term of a pattern? Or even a fraction? Do I ask you, please find the negative half term of a pattern? No. We want natural numbers. So behind me, I'm going to say that the natural number of 10 indicates the value of the pattern. So this specific pattern, where this pattern has a value of 290, it is the 10th term. So let's write that down. I know that n cannot be equal to negative 29 over 3. So n is equal to 10. So the 10th term will have a value of 290. Let's go to the next example, everybody. So we are now moving on to an example with the Olympics. So in the first stage of the soccer at the Olympic Games, there are teams from 4 different countries in each group. Each country in the group must play every other team in the group once. So I'm hoping that everyone's getting a bit excited because we're now putting sport into maths. I'm sure some of you thought that could never happen. But now we are imagining that we're at the Olympic Games. There's one group with 4 countries. Each of them are going to play each other once. We're then going to have a look at what would happen if there were 5 groups and 6 groups, or 6 teams in a group rather, and 5 teams in a group. And we're going to see how many matches would be played. So let's have a look at the actual questions for this example. So, how many matches will be played in each group in the first stage of the event? So that's essentially where we have 4 teams. Then we're going to see how many matches would be played if there are 5 teams in each group. Then see how many matches would be played if there are 6 teams in each group. Then we are going to determine the general formula of the sequence. So, first things first, we have 4 teams in one group. We're now going to see how many matches would be played. So let's look at the grid together and we're going to work it out to see how many games are going to be played with 4 teams in one group. Great, so if I'm looking at Team A would have to play Team B, they would also have to play Team C, and they would also have to play Team D. Team B would then have to play Team C and Team D, because B has already played A, that's why I haven't written it again. Team C would then have to play Team D. So over here, we can see that there are 1, 2, 3, 4, 5, 6 matches. If there are 4 teams. The reason why I haven't put any teams in over here for D is because they've already played every one. That's question A. Question, we've already filled that in. Sorry, that's a repeat of the slide. For question B, we're going to see how many matches will be played if there are 5 teams. We can see that Team A will play B, C, D, E, going on and on and on until you see that the last game is between D and E, which means that there are 10 games. Then if there were 6 teams playing, if you were to write down all the possible combinations of games being played, we can see that there were 15 matches played. So guys, I hope that you can see that all that's been happening on the grids behind me is matching teams together and seeing how many games would have been played. We're now going to look at the amount of matches for 4 teams, 5 teams, and 6 teams to see if we can determine the pattern. So we can see that we had 6 games for 4 teams, 10 games for 5 teams, 15 games for 6 teams, and it's going to go on and on and on. So let's analyze the pattern. So it's going to be 6, 10, 15 going on. I'm going to fill in the 21 over here. The first differences between these two is 4. First differences between those two is 5. First differences between 15 and 21 is 6. The second difference is equal to 1. So let's determine the general form of this sequence. So again, we've got 4, 5, and 6 determining the first differences. Second difference is a value of 1. To determine the general form, we know that we have to say that 2a is equal to the second difference, which is equal to 1. So a will be equal to a half. Then we say 3a plus b will be equal to the first term of the first differences, which is 4. So I'm going to have 3 times a half plus b is equal to 4. So I'm going to have 3 over 2 plus b is equal to 4. If I multiply everything by 2, I'm going to have that 3 plus 2b is equal to 8. So b will be equal to 5 over 2. Then last but not least, let me just erase that. And lastly, a plus b plus c is equal to the first term of the entire sequence, which we can see in this case is 6. So I'm going to have a half plus 5 over 2 plus c is equal to 6, which means I'm going to have 3 plus c is equal to 6. So c is equal to 3. Let's just conclude the general form for this quadratic sequence will be a half n squared plus 5 over 2n plus 3. Great. Thank you so much for joining me for quadratic patterns today. I hope that the rest of your day goes very well.